is it visible? Windows OneNote.
Yes, sir.
Okay. Last time I'm discussing about where it is. This type of map, what is kernel, etc. So, what is your guess? What is kernel? Hello, anyone? Have you done this problem?
Sir, I sent you.
Yes, you sent. You means 1 minute. What is your name?
Rahul. Rahul Mohan.
Yes. Let me see your message. Where is your message? 1 minute. Yes, yes. Hi. Yes, yes, yes. So you claim that kernel theta is. I'm writing your draw. You claim that kernel theta is generated by y square minus x cube comma z square minus x to the power 5, and uh, it is obvious that y square minus x cube minus x cube z square minus x to the power 5 is subset of kernel theta. It is obvious here. That is your claim. You have written that if fxy then z belongs to kernel theta, then what is dividing? You have written fx y z by z square minus x 5 uh, into g1 x y z plus p0 xy, absolutely right, plus p1 x y z. Now you written that p0 again divided by y square minus x cube. Then you have I think r0 g2 xy plus r0x plus r1y r1xy. I am not writing all details. It is understood that p0xy belongs to kxyz. I just write one line kxy p0 y comma p1 xy belongs to kxy, and r0x r1x kx. So finally when we apply, and p1x similarly is your y square minus x cube g3xy plus s0x s1xy s0 s1x lies in kx. Now apply, so fxyz is z square minus x to the power 5 g1 x yz plus y square minus x cube g2 xy r0x r1y plus y square minus x cube g3 xy plus s0x plus s1 xy whole thing into z, right? Applying theta, then what happened? It is 0 because it is lies in kernel. This is also 0 plus 0 plus r0, what is x, r0 t square, r0 x is t square
Yeah.
plus r1, what is y,
TQ.
y is t cube plus s0 t square s1 t cube, what is y, sorry, s1 t square, sorry, r1 I think t square, I've written wrong here, r1x, so r1 t square, similarly t square into t cube total into t to the power 5, right? Now question is, what next? You, can you conclude anything? Can you conclude anything?
Primarily, I was thinking that it will be 0, but
No, it may not.
hmm.
But somehow in my example it works because it is nicely arranged. So when you have approached, same way, but you stuck, right?
Yes.
So you can do this problem by the same way. Try it, this problem by same way, but here you cannot do this problem by same way. So we need better technique. This technique is called Gastinger. I will do it later. Okay. How to find kernel of K? Actually, see it. One thing. You see that if I write uh, 5 3 y cube minus zx square, right? No, z minus xy, sorry. If I add this z minus xy, z minus xy also lies in this kernel, right?
Yeah, yeah. Hmm.
If I write z minus xy, then one p1 is dropped. I remove this part. Okay. You, means I want to say that I am choosing this generator. Then what? Then this is z minus xy p0x, only this, right? This
Then
part.
this jet dependent term will vanish. Yeah,
Yes.
disappear.
So it is some short. uh, okay. Then eh, sorry. So I have no p1. I have no p1 this part, right? So I can write z minus xy, then I can write here only this, right? Then applying theta, what happened? Then can you say something? Actually no. No. You have r0, g1, r1, y, right? Y here. So I can write y. Y means t cube, right? Y means
Yeah.
t cube, right?
Yes, sir.
Let r0x equals to a0 plus a1 x plus an x to the power n. r1x equals to b0 b1x bm x to the power n. Then what happened? r0 t square is a0 plus a1 t square an t to the power twice n, right? r1 t square is b0 plus b1 t square bm t to the power m,
Some coefficients are still dependent.
t to the power twice m. Now what happening is here r0 t square plus r1 t square t cube, then a0 plus an t to the power twice n plus b0 bm t to the power twice m into t cube. That means ai equals 0 equals to bi bj, because here all terms are even, t to the power t8 t square something, and here all are
Oh,
odd,
okay,
no
sir. Okay,
cancellation.
okay. Yeah.
So in this case again you are lucky. So luck is a factor here, but there is a systematic way. Okay, I will
And also the
discuss it
correct
now.
guessing of the kernel.
How to find this kernel? Herzog, Zargen Herzog has proved that. So, has proved that if I take three variable in domain like that x y z, then the kernel is generated by either two element or three elements. Here two elements. Okay, it is proved that not always two elements. Sometimes it is generated by three elements also. Okay,
Okay.
if you uh, want to think that 3 4 no, 3 5 7, then what happened? You will say next, answer this question. Okay, I'm happy that you have tried. Answer this question, this fellow. Okay,
Yes, sir.
so there is a systematic, don't worry, there is a systematic method, but this method needs some more algebra, so you have to wait. Okay, now I do some things. Jacobson, Jacobson ideal. At first, some proposition. What happened? All of you, you know that the book of Artin's book, second edition. So there is some exercise in this book, Artin, and Hungerford book also. Try those exercise. Such that every x r minus m is a unit in R, then R is a local ring and M its maximal ideal. Proof is very simple. Every x r minus m is a unit. Then R is a local ring and M is maximal radius. What are the set of units? Hello.
Yes, sir. Hmm.
Set of unit.
R minus M. Every
In any ring, you know that ring means commutative ring with unity. In that type of rings, every non-unit element lies in a maximal idea, right? If A is in general any ring means commutative ring with identity in my setup. So A is non-unit, then A lies in some maximal ideal. Sorry, A belongs to some maximal ideal. So set of unit is R minus union of maximal ideal, right? So here if one maximal ideal, then R minus M is unit. So if R is local, then R minus M is set of unit. But this is converse type. Okay. So prove it. It is very simple. Let some M1 belongs to max spec R. A belongs to M1. This implies A is not unit. This implies A belongs to M. Since R minus M, every element of R minus M is unit. X belongs to R minus M imply X is unit. So but this implies M1 is subset of M. Since M1 is the maximal ideal, this implies M1 equals to M or M equals to R. Since 1 does not belongs to M not equals to R. This implies M1 equals to M. So max spec R equals to M. Okay.
and then the ring is called local ring.
Yes, the ring is local. Observation 2. Why local ring is important? Local ring is so important because in future, whenever you go to algebraic geometry or something, some things you have to see locally. That means smoothness and birationality, whatever. This terminology I am not going to this. You have to check locally, then you have to go localization, and localization means there some I will teach you localization, but they are local ring, all local ring. So let R be a ring and M belongs to max spec R such that every element of one plus M is unit. R. Then A is local ring. Then R is a local ring. Proof. Let X R minus L. Consider M plus X R. M plus X generated ideal, that means XR. That strictly contained in M, as X does not belongs to M, but X belongs to here, M plus XR, because 0 plus X into 1. This is ideal, I plus J ideal, you know that. Now since M is the maximal ideal, and it is proper containment, this implies 1 belongs to XR. So 1 can be written as A plus XB, where A belongs to M, B belongs to R. So XB equals to, what is this? 1 minus A, I think. A, and that belongs to 1 plus M. This implies XB is a unit. That means X is a unit, because what do you mean by unit? X B V equals to 1 for some V, so X into some U equals to 1, because take U equals to BV. Okay, therefore by 1, by the previous proposition, R is a local ring. Now I am doing some problem. One observation is, all of you know that if R is an integral domain, what do you mean by integral domain? There is no zero divisor, right? Definition: let R be a ring. Ring means commutative ring with identity. such that for all x belongs to R, the homothety R to R theta x R goes to Rx is injective. Or you can say that zero ideal is prime ideal. Then R is called an integral domain. Note that R is an integral domain even only if zero ideal is a prime ideal. Okay, that is another definition, that zero ideal is a prime ideal. Okay, one observation is if R is an integral domain, then Rx is also integral domain. Why?
We can directly take two polynomials
Yes, yes.
over R,
Tell me.
and then we can take two polynomials over R, say fx and gx. Fx dot gx equals to 0. Then
Okay, because leading term, if there exists gx belongs to Rx, such that fx 0, take such gx with minimum degree. I think I write take such px. I write px with minimum degree. Let px, there are so many, there may be so many gx that fx into gx equals to 0. I take minimum one, minimum degree. Minimum means minimum degree. Px equals to b0 now simply multiply and this imply an bm equals to 0, contradiction, an not equals to 0, m not equals to 0 and R is an integral domain. Okay. Next question is, these are very standard question. I think you probably seen it, but I have to do. Let R be a ring and Rx polynomial ring. F is unit in Rx if and only if A0 is unit and A1 are nilpotent. F is nilpotent A0 N are nilpotent. Now, what is? Can you answer this question? What is the nil radical of a ring? Hello, answer me.
Root I equals to 0.
Intersection of all prime ideal, right?
Yeah.
Where I have done that is this proposition. Nil radical is intersection of all prime ideals. So I have to show that in the first problem, I have to show that A0 is unit, number 1, and A1 to AN are nilpotent. That means you have to show that A1 to AN belongs to intersection of all prime ideal of R, right?
Yes, sir.
Proof. Proof. Suppose F is unit. So there exists Gx to Rx such that Fx Gx equals to 1. Let Gx equals to B0 x to the power m. So A0 plus an B0 x to the power m is 1. Comparing constant but degree 0 element, we have in R. So I have to say that in R, in R. Now you have to show that A1 to AN lies in your. Now let lies in any primary. Let P belongs to spectrum of R, a prime ideal of R. Then R mod P an integral domain. This implies R mod Px is an integral domain. Now one observation I have to write, that if R is integral domain, what are the units of Rx? Can you say? If R is integral domain, then what are the units of Rx? I am using, if R is integral domain, fact. I'm proving this. I'll prove this. At first I can prove here at pages 22. I think I should prove it first. If it is a previous result, if R is an integral domain, then units of Rx equals to units of R. Prove. It is obvious that is obvious that units of R is subset of unit, because if it is units in R, then R into let A be unit in R, then AB equals to 1, therefore AB it is units also Rx. Now converse, let Fx units of Rx. There exists Gx such that I write it is with ANBM0. This is BM. So by induction we can say, or by continuing this method, we can, by continuing this method, this process, we can say that so no, this is one, I think. I just to one. This implies ANB0 equals to 1. B0 is not 0, otherwise it is 0. As AN not equals to 0 and that is if n greater than equals to 1. Done. Units of R of R. Now back to this problem. So I have shown, we see that units of Rx is equals to units of R. So all units of Rx come from R, coming from R. Now here, so R mod P is an integral domain, right? Consider the homomorphism consider the ring homomorphism R2 pi R mod Px B0 plus goes to now under the homomorphism unit goes to unit, right? fx because 1 goes to 1 in homomorphism, unit goes to unit. Fx belongs to Rx is a unit in Rx. This implies pi fx is a unit R mod px. That means a0 plus p n plus px to the power n is unit in px, but R mod px is an integral domain. This implies units of R mod px equals to unit of R mod p. This implies all x degree terms should, this a0 plus p, this should lies in R mod p, an plus lies in R mod p. So all x term should be coefficient of all x term should be 0. This implies ai plus p equals to 0 plus p 1 less or equals to I less or equals to n. This implies ai belongs to p. Since p is chosen arbitrarily, ai belongs to intersection of p. This is Specker. Any prime ideal 1 less or equals to I less or equals to n. This implies a1 an are nilpotent. So this is a problem, first problem. Now converse part. For converse part, we also see an observation. Some observation I am doing in next page. See that if x is nilpotent and a is unit, then a plus x is unit R. Can you prove this? This is very easy. X nilpotent and a is unit, then a plus x is unit. How to prove it?
Something a plus x whole to the power m, we will then break it.
Prove x is nilpotent. This implies x to the power n equals to 0. Now 1 plus x, 1 minus x plus x square minus what is this? I think 1 minus x to the power n, right? What is the
Yes,
formula?
sir.
That is 1, right? Now a unit, a is unit r. This implies ab equals to 1 for some b belongs to r. Now a plus x equals into b equals to 1 plus bx, 1 plus x dash. X dash equals to bx is also nilpotent. As x dash to the power n equals to b to the power n, rings are commutative, so I can say that b to the power n x to the power n. This is not true in non-commutative ring. What is this? So b a plus x, 1 minus bx plus bx square n minus 1 b to the power n x to the power n is to this implies a plus x is the unit. So it is the proof. So unit plus nilpotent is unit. Unit plus nilpotent is unit. So this is observation. Now I am going to here, back to this problem. Conversely, let a0 is unit and a1 an are nilpotent. This implies a1x plus a1x comma a2x square. If we multiply something with nilpotent, then again is nilpotent. A n x to the power n are nilpotent. Are nilpotent. Now nil radical is an ideal. So sum of nilpotent is nilpotent because it is an ideal. This implies a1x actually I should write nil rx, not nil rat. This is standard notation. So it is nilpotent element. Unit plus nilpotent is nilpotent. Is unit, sorry. Unit plus nilpotent is unit. Okay. It is unit in R, hence in Rx. So unit plus nilpotent is unit. So here is a complete characterization of unit in polynomial ring on one variable. Can you extend this for several variables? That means kx, 1x, sorry, rx1, x2, xn. Can you say? Problem number 2 is homework. Same thing. Proceed by same argument. Okay. Problem number 2 is homework. Try. If it is, if there is problem, it is not done by you, then I will do next. Problem 2, not 2, I should write part 2. I should write part 2. Homework. Next I define here something called Jacobson radical. If you have any question, please ask me.
Sir, what will happen for several
Huh?
and
Huh?
several variable? What will happen for several variable?
Several variables are x1, x2, xn. Find all units in here. You try to add xy, two variable. Okay.
Oh,
Let R be a ring, then Jacker intersection of maximal ideal is called Jacobson radical. By the way, have you read the book by Jacobson? It is a good book. কিছু বই আছে পড়তে হয়। সার্জল্যাং algebra, graduate text in mathematics. Hungerford, Jacobson, Artin. It's called the Jacobson radical of R. So you know that fact, since max spec R is subset of spec R, this imply nil r equals to intersection of p r is subset of jack r that is defined by intersection of r. Is it clear? So nil radical is subset of Jacobson radical. Is it clear? Because every maximal ideal is prime ideal. Okay. Now I am closing with this question. Can you compute Jacobson radical of Zx? Can you compute Jacobson radical of Zx? Now what is nil radical of Zx at first? Tell me what is nil radical of Zx? Anyone? Just oral question it is. Z is integral domain. Therefore Zx is integral domain. In an integral domain, nil radical is only zero ideal. Because x to the power n 0 means x equals to 0. Okay. Or you can think that it is integral domain intersection of all prime ideal. 0 is prime ideal, so 0 is there. Therefore nil radical is 0. So nil radical of Zx is 0. So what is Jacobson radical of Zx? Can you say something?
I think it will be 0 also.
Hmm. Carefully. Fact. Prove it. Let R be a ring. Let R be a ring. X belongs to Jack R. If and only use this fact. At first prove this fact, then use this fact to find Jacobson radical of I think I write Rx. R is a ring. Find so this is okay. So if you have any question, please ask me. Otherwise, I will leave.
Sir, I have a question.
Yes.
স্যার ক্লাস থ্রিতে আপনি একটা এক্সারসাইজ দিয়েছিলেন, নীল রেডিকেল বার করতে বলেছিলেন জেড বাই এন জেড এর।
Hmm.
তো সেটা কি জেনারেটেড বাই পি1 পি2 পিআর বাই এন জেড এরকম টাইপের হবে, যেখানে পি1 পি2টা প্রাইম নাম্বার?
n এর প্রাইম ফ্যাক্টরাইজেশন আছে তো?
হ্যাঁ, এন এর প্রাইম ফ্যাক্টরাইজেশন আছে, পি1 টু দি পাওয়ার আলফা ওয়ান অ্যান্ড সো অন, যেখানে পিটা প্রাইম ছিল। তো
হ্যাঁ, তাহলে
জেড বাই
p1z ওর স্পেকট্রামটা হবে কি? স্পেকট্রামটা হবে p1z কোশেন্ট nz, p2z কোশেন্ট nz এই করে
হ্যাঁ
করে।
স্যার,
তাহলে
হ্যাঁ
নীল রেডিক্যাল হবে এদের ইন্টারসেকশন।
হ্যাঁ, এদের ইন্টারসেকশনটাই বলছি, মানে তাহলে আনসারটা কিরকম ভাবে লিখবো যে
এবার
আম,
1 মিনিট। এবার
হ্যাঁ,
প্রশ্ন হলো যে জেড এ P1Z ইন্টারসেকশন P2Z মানে কি হয়? P1 P2Z জিসিডি যদি মানে 1 হয়, জেড এর মধ্যে ধরো এখানে একটু রাফে লিখছি, ঠিক আছে? P1Z intersection P2Z, can you write P1 P2Z GCD P1 P2 distinct prime, এটা লিখতে পারি?
স্যার যদি ওয়ান এলিমেন্টটা এদের প্লাসের মধ্যে থাকে তাহলে
1 তো
সম্ভব।
থাকবেই, জিসিডি 1 তো, P1 P2।
হ্যাঁ, তাহলে সম্ভব।
তাহলে এবার ইন্টারসেকশনগুলো ক্ল্যাপ করিয়ে দাও,
ওকে স্যার।
ঠিক আছে? তাহলে হয়ে
ওকে
যাবে
স্যার।
প্রোডাক্ট P1 P2 PN Z কোশেন্ট NZ, ঠিক আছে?
হ্যাঁ স্যার।
যদিও তুমি ওই যদি আগে আগে ওই পর্যন্ত লিখে রাখতে যে P1Z কোশেন্ট NZ P2Z, সরি P1Z কোশেন্ট NZ ইন্টারসেকশন P2Z কোশেন্ট NZ, এগুলো লিখে রাখলেও ঠিক আছে, কারণ ওখানে কোশ্চেনটা দেওয়ার উদ্দেশ্যই হলো তুমি স্পেকট্রামটা বের করতে পারছো কিনা, এবং ওই স্পেকট্রামটা বের করাটাই তুমি আমাকে দেখাবে লিখে, আমাকে মেসেজ করো, আমি দেখব।
হ্যালো
ঠিক
স্যার,
আছে স্যার।
হ্যাঁ বলো।
বলছি ওই যে একটা কোশ্চেন দিয়েছিলেন না যে কে একটা ফিল্ড হলে কে অফ এক্স ওয়াই, তা মানে সেটাতে আই এন্ড জে যদি আইডিয়াল হয় তাহলে আই ইন্টারসেকশন জে ইজ ইকুয়ালস টু আই জি ইফ এন্ড অনলি ইফ হোয়াট।
হুম।
হ্যাঁ, তো আমি ওটা ওয়ান ভ্যারিয়েবলের জন্য করেছি।
হুম।
তো আমি এভাবে করেছি কেটা ফিল্ড, তাহলে কে এক্সটা একটা ইউক্লিডিয়ান ডোমেন,
হুম।
তো কে এক্স একটা ফিল্ড পিআইডি। তো সেখান থেকে আমি ওই দেখাচ্ছি যে যেহেতু পিআইডি, তাহলে ওই আইটা হচ্ছে জেনারেটিং বাই পি অ্যান্ড যেটা হচ্ছে জেনারেটিং বাই কিউ, দেন আই জেনারেটিং আই ইন্টারসেকশন যেটা হচ্ছে এলসিএম অফ পি কিউ দিয়ে জেনারেট হচ্ছে। আমি
আমাকে
কি স্যার
শুধু
এটা?
উত্তরটা বলো দেখি তো, যে কি
হ্যাঁ,
ইফ অ্যান্ড অনলি হোয়াট।
ইফেন আমি ওয়ান ভেরিয়েবলের জন্য দেখতে পাচ্ছি যে ওই আই কেটা বিলং করে যাবে।
ইফ অ্যান্ড অনলি ধরো আই জেনারেটেড বাই এফ এক্স, ওয়ান ভেরিয়েবল মানে পিআইডি, আই জেনারেটেড বাই
হ্যাঁ।
এফ এক্স, জে জেনারেটেড বাই জি এক্স, তাহলে
হুম।
আই ইন্টারসেকশন জে ইকুয়ালস টু আই জি ইফ অ্যান্ড অনলি জিসিডি এফ এক্স জি এক্স ওয়ান,
হুম।
এটা
বা-
দেখিয়েছো তো?
না না না, জিসিডিটা তো ইউনিট আসছে, একটা ওয়ান তো আসছে না।
আরে
তো
বাবা, ইউনিটকে তুমি ওয়ানই ধরো, কে
হ্যাঁ,
এক্স
তো
এর মধ্যে
সেখান থেকে
ইউনিট
আমি
মানে এটা কে এর, কে এর ব্যাপার তো।
বেজস অফ পিআইডি দিয়ে আমি দেখালাম ওয়ানটা বিলং করে যাবে আই প্লাস যেতে।
কে তো ফিল্ড, তুমি জিসিডিটাকে ওয়ানই বলো।
আচ্ছা ঠিক আছে, তো ওয়ানটা বিলং করবে আই প্লাস যেতে, ইফ অন ইফ কন্ডিশন হচ্ছে সেক্ষেত্রে।
হ্যাঁ সেটা স্বাভাবিক, ওটা
এবার এটা কি,
ইউক্লিডিয়ান
এবার এটা
ক্রাইটেরিয়া।
কি টু ভেরিয়েবলের জন্য আমার সমস্যাটা যেটা হচ্ছে, টু ভেরিয়েবলের জন্য আমি একটু মানে এটাকে আমি ওই পিআইডি এটা তো দেখা মানে গসের যে থিওরেমটা ওটা ইউজ করে তো আমি তো শুধু বলতে পারবো যে ওটা একটা মনে হয় খুব সম্ভবত ইউনিক ফ্যাক্টরাইজ ডোমেন হবে, তার বাইরে কি কিছু বলতে পারবো আর? কারণ আমি ওইটার আবার
টু
পলিনোমিয়াল।
ভেরিয়েবলে পারবে না বলতে এখনো,
আচ্ছা।
ইভেন ওটা আলোচনাযোগ্যই নয়, আমি ওটা বলেছিলাম যে ওটা বেশ কঠিন হবে। তুমি একটা কাজ করতে পারো, স্পেশাল কোনো আইডিয়াল যে এই ক্লাস আইডিয়ালের জন্য এটা হতে পারে,
বুঝলাম
যেমন
না
ধরো
ঠিক।
মোনোমিয়াল আইডিয়াল, সেখানে করতে পারো, মানে জেনারেটেড বাই মোনোমিয়ালস, সেটা বেরোবে,
আচ্ছা
সেইটা বেরোবে, কিন্তু জেনারেল আইডিয়ালের ক্ষেত্রে বেরোনো এখন সম্ভব নয়। এখন কি মানে তোমাকে পিএইচডি করতে গেলেও তোমায় ভাবতে হবে এটা।
আচ্ছা
ওকে।
স্যার, আরেকটা ডাউট ছিল ওই
হুম
আগের দিন ওই
বলো।
সিস্টেমেটিক পলিনোমিয়াল লেখার ব্যাপারটা নিয়ে একটু ট্রাই করছিলাম, নাকি পাঠিয়েছিলাম।
কোনটা?
ওই সিস্টেমেটিক ওয়েতে পলিনোমিয়ালটা ফাইন্ড করার জন্য আপনি একটা প্রসেস বলছিলেন।
দেখি তোমার চ্যাট। এটা তো আজকে সিআরটি করালাম না, যেদিনকে সিআরটির ওই মডিউল ভার্সানটা করাবো, ওই দেখো আমি ভেক্টর স্পেস বলে রেখে দিয়েছি আমি, ওটাতে
হ্যাঁ
আসবে
হ্যাঁ,
আবার পরে।
আমি দেখতে পাচ্ছি। হুম,
ওই দিনকে ধরে ধরে করব, ঠিক আছে?
ঠিক আছে।
মনে করো ওই দিন।
ওকে।
ওকে।